Great, welcome back. We're going to work on the third exercise from regression practice problem. Okay, we have a linear regression. Y is stock price. There are three x's used. X1 is quarterly dividends. X2 is price earning ratio, and X3 is interest rate of treasury bills. Okay, the number of observations we used is 40 quarters. So sample size is 40, so you can write down. And we have three x's. So K usually represent the number of x, so that's 3, right? So those are some essential information you want to drop down while you're answering the question. What we have here is a printout from a software we got. We used to teach this class in Stat Graphics. Now we move on to Excel, Stat and Excel, but the output of them is identical, as you can see. Okay, so there's a bunch of questions for us to answer. And before we are able to do that, I'm going to first start filling a lot of blanks, question marks here in this table. So let's start. Okay, so first of all, there are a bunch of question marks here. And what we want to do is we want to use the relationship between those three columns. Last time we talked about T-stat. I'm going to write it down here. You can see the first question from regression practice problems video as well. So T-stat is the estimate divided by standard error, right? So that means this column, you can use the first column, divide the second column. Okay, so clearly you should be able to see, you can find T-stat. T-stat can be found using 17.39 divided by 5.5254. I'm not going to write it down. You can check your answer. It should be 3.1477. Maybe there's a little bit rounding issue. You can also see that here for this quantity, it's going to be the product of 7.5016 with 5.5054. And that's going to be close to 41.2993. I'm going to fill in the rest of the column as well using the same kind of relationship. Okay, and what we want to do next is there's a p-value that's missing here, so we want to figure out the p-value. Remember, the coefficient table, the p-value is always for two-tailed test, right? I talked about last time in our first question. Okay, to figure out this particular p-value, what we need is degrees of freedom because it's a t distribution. So n minus k minus 1, that's 40. We talked about n 40, k is 3. We used the 3 axis. So that's 36. Okay, and next is we are going to use t dot dist function. So what we have is the test statistic of 5.504. Degrees of freedom 36, true. Okay, that's going to give you the area completely to the left. Okay, for two-tailed test, what we want is we want this area. We also want the area to the left of that, right? Okay, you want to find the small corner first, and then you multiply by 2. Okay, so I'm going to find a small corner, which is 1 minus that, and then use 2 multiply by it. You should be able to get the p-value to be very close to 0. So this is actually very close to 0. Okay, and now we're going to move on to the next ANOVA table, the second portion of the table. Okay, so I'm going to start from the first column. The very last entry here is SST, total variation. And the model refers to SSR. Okay, and the residue is SSE. I want to emphasize here, sometimes I've seen students thought the residue is SSR because they are star R. The R actually stands for regression. You probably also remember we talked about the relationship between the sum of squares and the relationship SSR plus SSE gives us SST. So what we have here today is we have SST, we have SSE. Can we figure out SSR? Yes. So we have this, and this one. So that means you can easily use 697 minus 180 to get SSR. And that's going to be 516.945, right? Next, we're going to move on to the degrees of freedom column. So degrees of freedom, the very last one is n minus 1. We know sample size is 40 minus 1, that's 39. So here is 39. I like to figure out the degree of freedom for the model, for the regression model, because this is the number of x's used in your model. We have x1, x2, x3 here. So certainly this entry is 3. And degrees of freedom also have a relationship. The degrees of freedom for model plus the degrees of freedom for residual gives out the degrees of freedom total. So 3 plus something gives out 39. So that something should be 36, right? For mean square, what we need to do is we can use sum square divided by their corresponding degrees of freedom. So for example, the very first one, that's going to be mean square for model MSR. You can use SSR 516 or 17 divided by 3. Okay, so that's going to give us 172.315. There may be a little bit error due to rounding. And for the mean square of error, for residual part, it's just 180 divided by 36. Okay, so that's going to be very close to 5 or 5003. Okay, we're almost done here. So the very last entry we have left is our test statistic, which is known as F ratio or F stat. F ratio is just a ratio between the MSR and MSE. So that's 172 divided by 5. And that's 34.442. Right? Okay, there's one more thing, standard error of estimate, right? Standard error estimate is, I'm going to write down, is actually square root of MSE, but you have to figure out where MSE is. MSE is mean square of error. The E comes from error, so it's this entry. Square root of 5003, and that's going to give us 2.237. Hooray, we were able to complete this table. Let's work on the questions. The first one is, what is the estimated value of beta 1? So that's a slope for the first x1. Well, we have that. That's 41.2993. 41.2993. Next one, what is the value of SSR? Well, SSR, we have it here, 516.945. And what does SSR mean? It means the amount of uncertainty or variation that has already been explained by the model. 517 variation in our response, and the response is the stock price, can be explained by our model using those 3 axes. Next question is, what percentage of total variation in stock price has not been explained? Well, SSR represents the amount that has been explained by a model. So the part that has not been explained is SSE, that's 180. And this question asks what percentage of it. So you have to figure out the percentage. So the amount that not being explained is 180. So this is part C. Divided by total variations. And this is going to be 74%, 74.16%. Right? Right. So this is 25.837%. Right, right. This quantity is actually related with R square. I just realized that R square is not calculated here. Well, I'm going to do it here. R square is SSR divided by SST. That's 516,945 divided by 697,040. That's going to be 74.163%. So the R square is 74.16, right? For our question part C, what percentage not explained? Well, it's 25%. So you can see those two. This part R squared represents the variation that can be explained, and this part is not explained. So those two add up to 100%. Right? Okay. For part D, test the hypothesis that beta 1 is 0 versus not 0. Two-tailed test. Beta 1 is related with x1. So let's take a look at the test. The test takes is 5.504 and the p-value is 0. Okay, so what we know here for part D is the p-value is for this particular two test is close to 0. So we reject null. We always reject null if p-value is too small. If p-value is very small, that means beta 1 is 0. This statement is wrong. So beta 1 is different from 0. So that means the effect of x1 on y is significant, right? So we can convert it and say quarterly dividends have a significant on y, and y is the stock price, right? Let's take a look at part E. Part E, this time we are interested in beta 3, so that's x3. Okay, we want to do a two-tailed test. Based on this regression output, which of the following is true, right? And so x3, the p-value is 0.00621. That's very close to the 6%. I'm going to write down here. So part E, the p-value is 6.21%, as you can see here. Okay, so if it's a 6.21%, we know that if the alpha, if the significance level is 5%, this is higher than 5%, we do not reject. But if the significance level is 10%, we would reject. We would reject now at 10% significance level, but we fail to reject at 5% level. Let's take a look at any of the options are correct. So the first one says do not reject 5%. Well, that's right. We fail to reject, but reject now at 1%. Well, if it's 1%, we also fail to reject. So the first one, it is wrong. B, reject now at 5% level. Well, we should fail to reject. So B is also wrong. And C, reject at 10% level. Yes, but do not reject. Wow, this looks right. Let's go over all of the options, right? You always want to do that. So do not reject at 1%. Yes, we do not reject, but reject at 5%. That's not right. And none of the above. So the correct answer is C. Question F. When the interest rate goes up, okay, interest rate, I think it is related with X3. When the interest rate X3 goes up, do you expect the stock price to go up or down? X3 has a positive slope, so we know that when X3 interest rate goes up, Y, the stock price would also go up as well, right? So okay, if X3 goes up, we expect Y to go up because beta 3, that's the slope for X3, is positive, right? It's positive. Okay, and let's take a look at the last one. So G, given the interest rate is 4 in percentage, price earning is 1.34 and quarterly dividend is 2.5. So we were asked to estimate Y. Well, this question, all we need to do is we want to plug in the numbers into our estimate equation. So first of all, we want to write down the estimate equation. Okay, so our estimate equation, Y, which is stock price, the estimate hat equals to 17.3925 That's the intercept. Okay, plus 41.293 times x1 minus 0.4158 multiplied by x2 plus 0.57091 x3. So what we're gonna do is we want to move this one to the next page. So we're gonna plug in all the numbers. We know the treasury bill is 4. This is actually x3, not x1. So x3 is 4. Price earning ratio is 1.34. That's x2. And quarterly dividends is 2.5. So those are the values we want to plug in. And if you do that, you can plug all those numbers here. And that's going to give you y hat. And you will be able to get 122.37, right? So what is the estimated stock price? It's going to be $192.37. Okay, great. So one thing I want to point out here is if you take a look at the coefficient table, you may realize by looking at the p-value, the x1, which is quarterly dividends, is significant because the p-value is very small. x3 for the treasury bill, the interest rate, is also quite small, relatively small. Whereas for x2, which is price and earning ratio, the p-value is 43%. This is not small. So that means x2, the price earning ratio, is actually not significant on stock price. So in practice, I really recommend students to do is you rerun the regression model after removing x2. You probably want to remove this x2. You want to rerun the model. When you do that, your estimated equation model without x2, the coefficients for all of those numbers may change. So you probably want to redo that. Remove this x2 and rerun the model. You can see the estimates are all going to be different. And then you can plug in those numbers into it, right? Great. This concludes this video. I hope you find it useful.